Yeah, g'day ladies and gentlemen. My name is Peter Hutterer. I work for Red Hat, and today I'm just going to give you a rough overview of the various things that we've done in the input stacks over the last year or two. It's kind of a bit of a blurry timeline, but given that I wasn't at XDC last year, I figured that's a good 2 years is roughly a good time span here. This is not going to be... Okay, it's crashed. Well, hey. There we go. So this is not going to be about one single project. This is a couple of ideas. It spans a couple of projects. But I've divided the talk into roughly the sections of like stuff that we're currently doing, stuff that we already did in the last 1 or 2 years, and stuff that we're currently thinking about it if we get to that point. That's towards the end of the slides, obviously. So let's just go straight in. Stuff that's currently happening. One of the big features that should be coming over the next 1, 2, 3 months is high resolution wheel scrolling. Very important, it's wheel scrolling only, so on mice, we're not talking about high resolution touchpad scrolling, we've had this for years. Just a short explanation, if you have your average mouse device has a touch wheel, as you move it by 1 one wheel click or whatever you want to call it, you move it by about 15 to 20 degrees depending on the hardware device, you get 1 click, and the value you get from the kernel and from the device itself is usually a value 1. So as you rotate it by 360 degrees, you get about 24 values depending on the mouse. High resolution wheel scrolling is the same thing, except that you get more values. So you set the mouse into a specific feature, and then say if you have a multiplier, that's how it works, it has a multiplier of 4, instead of just going click, you go click, 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 click. Or, depending on the hardware, you might just get the same 15-degree motion, and you get a value of 4 now. Great, so it's not particularly useful. Or you might get a combination thereof, so you might get more events, but not the full amount of events. So like, for example, multiply 4, you might get 2 events with a value of 2. On the mice I have at home, I've seen every single combination so far. The highest multiplier I've seen so far is 16. So you get basically like one event per degree of movement. This is implemented in the firmware through 2 methods. One is the official HIT standard, the HIT resolution multiplier, which Microsoft added to HIT in whenever Windows Vista came out. So we're only about a decade late here to support this. Logitech has a similar protocol, the HIT++ protocol, which is their proprietary one, how they control their hardware features in the mouse. And they have a request in there that sets the multiplier. The HIT resolution multiplier is so far I've only ever seen it on Microsoft hardware. And I think, based on a sample set of 2 mice, that they've stopped using it about a year or 2 ago. So the mice that I have that are newer than about 2 years old, they don't seem to have that feature anymore. So if you have a mouse from Windows Vista release to about 2 years ago, it's almost certain that it has the resolution multiplier and you can get high resolution scrolling. In terms of software, we have support for that in the kernel as of kernel 5.0. Fairly simple API. We added 2 more axes, so rel wheel high res to complement the existing rel wheel and H wheel for horizontal wheel. That's basically it. So in addition to the usual one, if you have a multiplier of 4, the events you get from the kernel is you get a high-res event of 30, 30, 30, 30, and then bang, you get the actual wheel event on the 4th event. So we're backwards compatible. The big thing there is that the new axis doesn't give you degrees or something like that. It has a baseline of 120. So every multiple of 120 is one logical traditional wheel click. So again, if you move the mouse by your 15 degrees or whatever it's going to be, you get a value of 120 summarized up. If you have a multiplier of 40, that's why you get the 30, 30, 30, adds up to 120. That was one wheel click. Make sense, roughly? Reason why we picked the 120 is because that's exactly what the Windows API uses, and the reason why the Windows guys started using that is because 120 is an integer that has a lot of integer factors. So there's nothing magic about this particular, it just gives you a lot of different integer multipliers that you can then implement in hardware. And given that it's been the Microsoft API for 10 years, we might as well use that because all the hardware uses it. Very important, the new high-res wheel scrolling is a separate event stream. You cannot rely on a multiple of 120 to actually generate a traditional rel wheel axis event. So this is the simplified example. If you have a Logitech mouse, for example, they do things like directional reset or timeout-based reset. So if you scroll really slowly, you might end up having more or less than 120 before the equivalent traditional wheel axis. So if you are a client using that, you either use the old stream or you use the new stream, assuming 120 and so on and so forth, but you don't use both and assume they kind of correlate. In libinput, scrolling events are sent through as libinput event pointer axis. historical naming basically, that has 3 bits of information. We have an axis source, which is either wheel or finger or continuous and so on and so forth. For this talk, I'm only going to care about wheel. We have a delta in degrees for wheels, or in pixels for like touchpad scrolling and so on and so forth. And we have an extra value that gives us the axis scrolling in discrete steps. So on a traditional mouse, you get a pointer axis event with a source wheel, you get a delta of 15 degrees, and you get a discrete step of 1 for every wheel click. So we tried to, it's like, oh, sweet, we already have all the data. All we need to do for Hutterer scrolling is we just divide it by the multiplier. That didn't really work. Actually, no, let me talk about what didn't work. Mostly because nothing expects a discrete event of 0 on a wheel event, just because we've never really had it. Like every time you move the wheel, you always got a discrete event of 0. So everyone used that. It's like, okay, how many discrete events I have? I divide by that, move on. So you can see the issue, what happens if you start sending discrete of zeros. The X.Org Libinput driver, which is the one I wrote, actually divided by 0 and crashed the whole server. Slightly inconvenient user experience. And the other problem we have is that we don't have a baseline for the degrees. So if we start dividing this, previously it was easy. We give you a delta of 15 degrees, and we say this was 1 wheel click. So you can say, okay, this was a slow wheel click, fast wheel click, depending on the degrees. But if we now give you an event and we say, okay, this was 6.5 degrees, you're like, but how much was this? Because users don't think in degrees, users think in like how many clicks did I actually trigger on the wheel. So if we start doing, okay, here's a 6 degree, here's 6 degrees, here's 6 degrees, here's 6 degrees. And by the way, that was a full wheel click now. You can say, okay, I'm going to add this up. There was 24 degrees, so clearly 24 degrees is a wheel click. Except that's not true, because if the user changes scrolling speed, and they do all the time, you might get events like 6, 6, 12, 6. And I was like, okay, so is it now 30? Is it 24? You just don't know. So the only solution to that is basically we need to add a new input event to libinput, creatively named pointer axis wheel, with the axis source basically hard-coded to wheel, because we only ever sent that out for high resolution wheels anyway. The delta in degrees, because now it's fine. Discrete steps is always 0, because instead of that, you now get the V120 value. I don't think I have to explain that. Same thing as the kernel gives you. And that seems to work quite fine. Just like the kernel, this is a separate event stream. So if you're using libinput, either use the high resolution axis or the low resolution axis, but don't assume that the two correlate. So don't assume that for every multiple of 120, you get a traditional axis event. So if you do emulation of scroll wheels, for example, the X server needs to do that, you basically have to do that on your own now, which basically means you can just ignore the old axis. If you support this event, you just ignore the old wheel events. Fairly trivial to do. This is currently sitting on a branch. It works. It's not been merged into master yet. For Wayland, because that's the next level where we have to support it, should look roughly familiar. Wayland scroll events are sent as WL pointer axis events, which has 3 bits of information. You got axis source, wheel, finger, and so on and so forth. You have an axis value, which is in pixels, surface pixels, and you have axis discrete. And because Wayland is a serial protocol, you get multiple events for each logical event. You have the axis, you have the WL pointer frame that just says, okay, those 3 events were part of one logical event. One of the bigger issues we have in Wayland, though, is that we only have 1 WL pointer. In libinput, everything is per device. In Wayland, you just have 1 cursor, 1 pointer, and everything happens through that, which means that in the admittedly slightly niche case where someone scrolls with 2 mouse wheels at the same time, you don't know where the events are coming from. And of course, if you have 2 mice, there's almost a 50% guarantee that those 2 mice don't have the same resolution multiplier, or they might not have a multiplier at all. So you suddenly get the events of like 5 degrees, 10 degrees, and like, okay, was that one 15-degree movement? Was it 2 from 2 separate mice? And you cannot know because that information isn't exposed. There's a few other issues, like for example, no one likes discrete 0. Roughly the same issues with libinput there. The merged WL pointer I just mentioned, you can't scroll on 2 things at the same time without getting confused. There is a magic distance of 10, sort of more or less hard-coded. For historical reasons, Weston started out of converting a wheel scroll event to a pixel value of 10. Mutter, when it started adding the Wayland support, started doing the same. So if you're using Weston or Mutter, every wheel event will be sent with an axis value of 10. You get the discrete event on top, so you can undo that. If you look at WL roots, it just takes whatever libinput gives it in degrees and forwards that on. So if you're using WL roots, you get a different scroll distance for mouse wheels already than you would get on the Mutter or Weston, for example. I can't remember what X Wayland does. It doesn't really matter because on the client side, like GTK ignores that value anyway because it only uses the discrete value and then multiplies it up by 10. So it's a bit of a niche bug, but there's still like this magic distance of 10 in there somewhere. And the other problem is just protocol specifications are fairly rigid. We cannot, like with libinput, we cannot just say, let's divide everything by the multiplier, because there's certain requirements of we cannot, for example, send an access source event without a subsequent access event. But a subsequent access event needs to have the right degrees and so on and so forth. So it's basically, the specs were written fairly rigidly, which means we don't have a lot of leeway of just misinterpreting them intentionally to add new features. Solution to that is just, unsurprisingly, just like with the kernel and libinput, we just need to add a new access event. This is a simplified view. What you would get on the protocol then is you get your access source wheel, you get your v120 value, in this case multiplier of 3, just to fit on the slide. So you get a 40, 40, 40, and then you get the traditional access event of 10. So your old clients would get the access event, deal with that, and that's the discrete value. Your newer clients that support the high resolution values would just deal with the smaller events here with the high resolution events. The feeling of that, once that is all in place, is actually really smooth. It feels quite nice, works quite well in GTK. Just like with the kernel and the libinput, this is most likely going to need to be a separate event stream. If you really want to know what everything does, there's a message sitting on the Wayland devel list from a few months ago, where it's like detailed, like what does what in what way and how is it going to go wrong. Next big feature that I'm currently working on is libinput user devices. Usually in libinput, a device is supported in this way. We have a dev input event node somewhere at the top that speaks fdev to libinput. Libinput internally has a libinput device, some struct that contains everything, and then spurts events out through the libinput API to the client. Libinput user devices work like this. So in addition to the normal event nodes, we also have the client. The client basically says, I want a user device, like user space device, couldn't come up with a better name. I want a user space device. Here's a file descriptor. Please create a normal libinput device for that file descriptor. Libinput adds that to its internal device list, treats it just like any other device, and then spits out the events through the libinput API. This gives us a bit of a circle because the client that eventually receives the libinput APIs is also the one that told libinput to create the device in the first place, which is a little bit weird at first. So just the main reason why I'm working on this is the libinput test suite. There's a few other use cases where it might be useful is. The problems I have at the moment is the libinput test suite takes roughly 60 minutes to run. It runs on my laptop and virtually nowhere else because it has all sorts of timeout-based failures that if the CPU isn't exactly the same, like if it's faster, you're fine. But if you run it in a VM somewhere, the CPU is most likely going to be slightly less powerful. So suddenly some of the timeout-based tests will fail. Or even if my machine is under load, the tests will randomly fail. We've got things like button debouncing code that requires strict 80 millisecond timings. And if that fails, your test suite fails. The test suite needs root, it needs uinput, it needs udev, all of which are fairly non-trivial to obtain in a container, for example. So we can't actually run the full test suite in the CI at the moment. And it messes with the sessions. If you don't have your session set up correctly, your laptop will shut down during the test suite because we do things like testing power keys and suspend keys and lid closures and so on and so forth, all done automatically, so you get a lot of flickering on the screen. So the advantage of the user devices, and this is the main reason why I'm working on this, is that any file descriptor will do. Instead of having an actual event node behind it, libinput only cares that the file descriptor that you pass it to speaks fdev. So you need to describe what is behind that because we can't run the ioctls on it, but libinput doesn't care otherwise. And that opens up a whole bunch of interesting use cases. So one of the test things that I played with was a keyboard macro daemon where the compositor would create a socket, pass it to libinput, tell it this is a keyboard, and then hand the other end of the socket to an external debus daemon, and the debus daemon was firing in keyboard events for macros, for recorded keyboard macros. And that would go straight into libinput inside the compositor, pop up as a normal keyboard event inside the compositor, and thus work within Wayland just fine. So there's a few interesting use cases. Could probably hook up like braille displays maybe or something like that. If you have a use case that may be able to use this, let me know because I'm quite willing to accommodate for whatever you need there. We obviously have no udev dependency, which means we can run it in a container quite easily. And I'm currently thinking for the test suite to add some sort of a get time FD. Not 100% sure how now, but basically file descriptor that libinput queries like what's the current time as opposed to clock get time, because that makes it completely independent of the wall clock time, and it doesn't really matter if the machine is under load anymore. We can test all the timeouts to the millisecond. Current plan is that this is not going to be in libinput.so. One of the issues with the API at the moment is that the hwdb requirements that Libinput has internally kind of leak into the API. Might be a way around that. I'm not sure how to handle Quirks, which are like device-specific exceptions. So this is the first version of that. When I have it ready, is most likely going to be libinput testing.so or something like that. But again, this may be very useful for compositor testing as well. So if you have any ideas of like, you need to test a compositor inside a container and you need to emulate input events, this is most likely going to be the way to go, or the simplest way to go. Third big thing we're currently working on is XKB user configuration. Mainly motivated by changing a single key is incredibly hard when you're using XKB. So I don't know how many of you have ever tried to change a single key. If it's not part of the official xkeyboard config shipped packages option, like options and models and stuff, it's actually quite convoluted. You can do it. You can drop a file into your $home.xkb rules and so on, symbols directory. What you need to do is, as this looks like, you basically need to create a new keyboard layout. Let's name it custom or whatever. Then you include the keyboard layout you actually want to use. In this case, include US Basic. And then you say, I want to overwrite that one key with the new symbols. In this case, I overwrite tilde with a void symbol, so unset whatever tilde was previously mapped to. This needs to be in the right folder. You need to, depending on whether you use libxkb common or xkb comp and the server and everything, you need to set up the include paths correctly, and so on and so forth. As of yesterday, Rain pushed a patch out for libxkb common. It actually parses the home directory keyboard layouts first. So this is like the first step towards getting proper user configuration. Either way, so this is what you currently have to do, which means that everyone uses xmodmap, because in xmodmap, that's a simple line, you run it. Unfortunately, xmodmap has the life expectancy of the Dodo in the 60s and 60s, so once Wayland is going to be around, we cannot use this anymore, so we need to come up with a slightly better solution here. So let's go back. The pieces that are involved here is basically the conversion from RMLVO to KCGSD. RMLVO is what you guys use, so it's rules, models, layouts, variants, and options. That is what you set in your control center or on the command line. XKB internally converts this to keyboards, compat, geometry, symbols, and types. That's what XKB uses internally. And there's like all this, yeah, it's not always easy to remember. It's slightly made easier because, at least for rules, everyone uses fdev at the moment, except for Alan and the BSD guys. Models basically always maps back to fdev as well. So we really, at this point, we basically only have to care about layouts, variants, options. You probably never had to set any of the other ones. There is a second piece, fdev XML or base.xml on BSD. And that's sort of like a site database. That's an XML file that contains every single layout with every single variant combination, with every single option. And you can parse through this XML layout, and then you can present a nice GUI for the users to click on whatever layout they actually want. Problem there is like one comes from the rules files and like is compiled by XKB comp. The other one is an XML file. Just deal with it. So there's like two separate databases basically, which is a bit annoying. The rules files, this is what we need to look at because the layouts is basically what you write in the end anyway, and the options. Rules files look roughly like this. So the first section here means if on the command line you specify set XKB map minus option group shift toggle, what this translates to, it basically says in this particular folder, whichever one is hard-coded, open the file group, and from that file group, load the section shifts toggle. And that section contains something that I showed off before with the tilde override. And that basically loads then into your keyboard layout. Likewise for models, you have model key code, and you can see why everyone is using fdev, because unless you specify one of these particular models, like OLPC, everything maps to fdev anyway. The problem is, especially for symbols and particularly for options, there's just not enough useful wildcards. So we had a bit of a discussion and like, okay, how can we extend the option wildcards? Can we do that? But there's a bit of a UX issue and so on and so forth. So the simple solution that we've come up with so far, and that's what we're currently working on, is we just default to $home.xkb rules as the default rule set to load, as opposed to etc, other share x11 xkb rules. Which is the normal hard-coded one. So we just default to load the rules files from the user home directory, and if that doesn't exist, fall back to the system one. And inside that, there's a new statement inside those rules, the bang include statement, and that basically says, from the system folder, that's the %s, what that's going to resolve to, load the fdev rule set. So this gives you exactly the same behavior as before. You should still load all the ones that the system installs anyway, but you can override it with your custom rules before that.
But
like
does the compositor get run by not for users?
Yeah, so this is one of the things that we still need, where there's other changes needed. So the problem is now that, like with Wayland, you're fine, because the compositor runs as the user, usually. But with X, you have a problem because that might still run as root. So you might specify a keyboard layout that maps to the names, but those names are not accessible by the X server, which runs XKBcomp. I don't necessarily have a problem with that because that might be the killer feature that pushes everyone to Wayland. Or rather, it's too hard to fix for X that, I can live with that.
You just rerun XKB after you log in.
Yeah, except that then you don't get it on keyboard plugins and so on and so forth. So there's all this like, it'll work in Wayland because everyone uses XKB common there. X, trickier. That's the basic issue here. Second problem is, as I mentioned before, there's a site database that contains all the for the GUIs, for the graphical user interfaces. There's 3 parsers that are found quickly searching. libgnome desktop is the thing that parses for all the GNOME configuration. We've got Qt, which has its own parser inside, and we've got libxclavia, which I think hasn't been updated since 2013. And of course, none of these support the XI include statement, which you would use in XML to just include something else. So we either have to change all these parsers, or I'm currently talking with Ran, the libxkb common maintainer, to figure out, can we just add this as a libxkb common API, so that there's only one thing you query for, like, okay, give me all the layouts you possibly support, here's a list. So there's also fdev LST, which is the old format. It was deprecated in 2003 already, I think. But for some reason, login.ctl parses that. So login.ctl, if you use that to set the XKB setting, that actually looks at LSD. Doesn't really matter, it's the same source anyway, it's generated from the XML. So yeah, still a few pieces missing here, but we're eventually getting there. Last big thing that we're currently working on, and by we, I mean mostly Philip Lanes, is an intern at Logitech, I think for another week or so. I think his internship expires, not expires, what's the word? Finishes next week or so. Is ratbag emu, which is a mouse firmware emulator primarily for libratbag, obviously. Usually when we're talking to a mouse, because we want to configure like a gaming mouse, we want to change the DPI, it works that we have ratbagd, dbus daemon, speaks some device-specific protocol, like Logitech Hit++, through HitRaw directly to the mouse. Problem is that if you have a test suite or anything, that requires unplugging and replugging a lot of mice. So the idea of ratbag emu is basically we replace the mouse with an emulator that can pretend to be, say, a Logitech G500 or MX Master, and so on and so forth. Then we have a test suite sitting on the side. That emulator also exposes a REST API because it was the simplest one to write. And the test suite talks to ratbagd and to the emulator at the same time. So it basically goes to ratbag emu and say, like, please create a Logitech G500S. And then creates a UHIT device that looks like that, speaks the same protocol. Ratbagd sees, oh, there's a G500S. I'm going to query what DPI settings do you have, and so on and so forth. And then test suite can say, hey, ratbagd, did you find the G500S? Yes. What DPI does it have? 800. And it's like, no, because we created it with 1,000 DPI, and that's how we know whether we still speak the protocols. The goal here is that we basically have a complete firmware emulation interface, initially for Logitech, because that's where we have the best specs, so we can emulate any gaming mouse. All right, short list of things that we did over the last year or two. This is a Dell canvas, and that little thing on the side is a Dell canvas totem. So according to the canvas itself is basically like a screen tablet touch screen. So it's a screen, it's a touch screen. You see the pen, so you can use it as a graphics tablet as well. The totem is, according to the marketing videos, at least when you see how it's being used, it's an auxiliary device. So you use your pen, you put the totem on the canvas, it's detected by the firmware, and up pops a nice context menu, such as, you use Photoshop, you can change the opacity of the layer, or you can rotate it to change the brush size, and so on and so forth. So we tried to add this, or we added this to a few components. Kernel 4.19, Benjamin added this fairly simple API. We just have one new MT tool. So this goes through the apps MT, so the multi-touch interface, and it basically says, hey, there's a multi-touch thing, but this is actually tool type of a dial, so we need to treat it like a totem. In Libinput, we read this, we export it through the tablet tool interface. So if you're using the Totem, what you get is you use the pen as a tablet tool pen, use the Totem, tablet tool Totem. We added 2 new axes, so you can actually get the encompassing ellipse, so you know exactly how big the Totem is, so you can draw a context menu around it rather than underneath it, which is slightly inconvenient. The Wayland proposed API, I say proposed because I haven't actually sent it out, but it's, again, fairly straightforward. It's just more of the same. We add a new tool type, we add a size event, and we'll be pretty much done. The real issue here is with applications. The number of free software developers that have access to a Totem is somewhere in the single digits. I've never seen one. Benjamin has one, so that's how we did all the testing. The number, other than like obviously Benjamin, and I don't know who else possibly has access to a Totem, but it's not a lot. What we need is we need people who are willing to update all the toolkits and compositors to add Totem support. And then we need people who are willing to update all the applications to provide all these context-specific menus when someone plonks a Totem. So obviously, you know, if the number of people who add the support for a Totem is small, the number of people who have a Totem and can add it to toolkits is smaller. The number of people who have a Totem, can add it to toolkits and to applications is even smaller. And you're starting at single digits to begin with. There's only so many times you can filter before you arrive at 0. So the big problem is we have this support in the lower levels, but I don't think applications will ever have support for it, just because it's a lot of work to get this in for what is possibly what 3 users out there. So even if Dell gets really, really successful with that thing, it's unlikely ever going to be supported. If I'm wrong, please let me know. I'm quite happy to help you out if you're willing to add all this. But I suspect that, for example, the GIMP developers are not so willing to add all the complexity for the context-specific menus for a device that hardly any users actually have. One of the good things that came out of the Totem support in Libinput is we now have location-based touch arbitration. So previously what happened is if you put the pen into proximity of a tablet, we would just shut down the touch device. For some devices, that's handled in the kernel anyway, but there's other devices where, so for the Wacom devices, it's the kernel driver that handles it. For other devices, it's because the touch and the pen device might be from different OEMs or different manufacturers, so that's not handled by a single kernel driver. So Libinput would just shut down the touch interface whenever the pen was in proximity, because you will at some point rest your hand on the tablet as you're drawing, and you don't want that hand to generate touch points. So location-based touch arbitration basically means there is a magic area around the pen, which roughly looks like this. It's not 100% accurate, but close enough, where we shut down touch in that area, but everything else is still accessible. So this allows for two-handed interaction. You can use the pen to draw something and then use your touch, you use your finger to select the next tool or something like that. This feeds back into the Totem support because we can do this now, which means that applications like GIMP, Krita, Inkscape, and so on and so forth can start adding true bimanual support or interfaces that require 2 hands to manipulate. Once we have that, then suddenly adding devices like the Totem isn't that difficult anymore because we already have that bimanual interaction supported anyway. So we'll see how you go with that. That's available in Libinput 1.13 or 14. So it's already shipped a few months ago. It's only on screen tablets at the moment. So if you're using Intuos, which are used for the graphic here, that still shuts down the whole thing. Details. Another thing we worked on is TUI, is a GTK application for Wacom smart pads. That's currently 4 devices. That's the Bamboo Spark, the Folio, the Slate, which are all devices that are basically notepads. It's a physical notepad with a physical pen. You draw on it. Underneath the thing is a Wacom tablet that records all the strokes, stores it internally in memory. Later, you connect via Bluetooth LE, and you download all the data, and bam, you have your drawing that you drew on physical paper. You got it on your computer. The Intuos Pro is slightly different in that it's not specifically designed for that use case. The Intuos Pro, the most recent version, is still a normal tablet, but you can put the paper on top and use a special pen to interact with it. The application itself looks like this, just so you roughly have an idea. This is all my test drawings here. It doesn't need to be sophisticated as such. All it needs to do is it fetches the drawings from the device, it lets it download and save them as SVG, or as of 3 days ago, I think, as PNGs, and then you can open them with a proper application like Inkscape or something like that. This is not integrated into GNOME or anything. It doesn't need to be because it's a very specific side application, like a normal application. We had to reverse engineer the protocol. We got then, a few weeks or months ago, we got the specs from Wacom, thankfully. The specs don't necessarily do what the device does, or say what the device does, but it allowed us to clear up a few misunderstandings. Because one of the issues we have with TUI is that the only way you can download something from the device, you can only ever download the oldest file from the device. in order to get the next file, you have to delete the oldest file. Once you delete it, it's gone. So you better make sure you haven't lost any data as you downloaded that file, because if an artist is sitting there drawing something for 3 hours, you really kind of want to make sure you don't delete that accidentally. We're pretty good at that at this point, to not lose data at least. And we've got a lot of, even when TUI crashes after downloading and stuff, we've got a lot of recovery tools where you can still, the data that came down, we can reparse it, because we record every conversation with the device, so we can reparse the actual Bluetooth data in case we figure out, oh, we had a protocol parser, this actually means something else. We didn't expect that. So we can reparse that data to then get to the right SVG files and so on and so forth. So at least it's fairly safe. Let's talk about FDev. FDev, everyone's favorite driver until about 5 years ago or something like that. FDev, the current state, FDev is very much in maintenance mode. It had the last commit in May 2018, so roughly, 18 months ago or something like that. The last proper release where we still added functionality was 4 years ago, and it only had 19 commits since. We still ship it in RHEL 8, so there's that, because it's still a good fallback driver for all the crazy devices that just don't really straightforwardly map into, say, mouse or touchpad or something like that. Synaptics had the last release in November 2016, and it's had 9 commits since. So online, there's still a presence of people that prefer Synaptics over Libinput for a variety of reasons, but Synaptics is effectively dead. So if your touchpad doesn't work in Libinput, let me know now until the end of the conference. And if every one of your touchpads works, congratulations. Synaptics is dead. No one cares about it anymore. Not a single person. Since 2016, when Libinput superseded it, not a single person has stepped up and said, yes, I want to work on this. So, yeah. Talking about Libinput, Libinput is good and has a problem at the same time. Since Libinput 1.9, which is the release roughly 2 years ago, as I said, roughly 2 years ago, we've had 1,100 commits, of which 980 were by me. So, yeah, the bus factor is 1. So right now, the input stack you're all relying on has 1 developer. In those 2 years, we only had 4 developers that submitted more than 5 patches. We had about 50 developers in total. Most of them submit so there's a few features that were added and were like 1 or 2 patches, but most contributors to Libinput submit 1 is like, oh, my device is broken, I need a specific quirk, and that's it. So there's virtually no one else working on Libinput at the moment. Thanks to GitLab, we now have Bugzilla tags, or tags that we can attach to issues. I found out that as soon as I attached the tag help needed to an issue, that's an almost surefire way to never hear of that issue again. GitLab has been a mixed blessing. I'm much more efficient. The issue tracker is more useful. Just pushing to it and so on. And the CI is really useful, even though we can't run it all yet. Benjamin is going to talk about this in a second, though. From what I can tell, Libinput has 0 code reviews. Previously, I used to send the various patches to the mailing list, so I got at least the occasional drive-by review of someone, oh, there's a patch in my mailbox. I just glance over it. Now, every patch is like 7 clicks away in the GitLab interface. As far as I can I haven't gotten a single unrelated code review in about 2 years. So sometimes the people that actually want a bug fixed will look at the diff, sometimes. But unrelated code reviews does not exist anymore. So we have a problem there. Libratbag. We have a logo for Libratbag now, thanks to Andy. Libratbag suffers from... Libratbag was introduced, 5 years ago, I think? 4 years ago, something like that. Was supposed to be the one true mouse configuration API. That worked for about a year or so when we still had time. Since then, we just don't have time anymore, and we don't really have a lot of contributors either. So we support, thanks to Philippe, while he was working in Logitech, I don't know how many extra Logitech mice he enabled. So there was a lot of quirks that we just needed to add. So for Logitech mice, we're actually pretty good. We support some of the Steel Series ones. There's the eTech CD and so on and so forth. But there's not a lot of people who are willing to reverse engineer the mouse to actually get it to work. We still don't have a stable dbuzz API. There's been a laundry list of, like, these are the things we need to implement before we can say, yeah, we have a stable dbuzz API. That list has been there for like a year and a half now or something, and it looks like no one is actually willing to do any of the scaffolding work for libratbag. So we get a lot of people that want their mouse to work, but we don't have a lot of people that are willing to actually help out. So not sure what's going to happen there. Libevdev, yet another component somewhere in the stack. There's really nothing to report. Libevdev doesn't really need any changes at this point. There's a few optimizations, nothing worth mentioning. The only thing is that if you do need to access input devices, and you do like to write Python, there's Python libevdev, which is just a C. It's a Python API around the C library. It's a fairly decent API, I think. So use that, I can recommend it. There's also a Python fdev project, which works slightly differently. Underneath is the same thing, but it doesn't go through libevdev. Has a different API. But if you're interested, if you need to work with fdev devices directly, look at that one. One of the things, again, a year or something ago, a year and a half ago, we added something called Libinput Quirks, simply to fix the case of like a lot of input devices out there need a this device is broken notifier in one or two ways. That goes from things like devices claim to have buttons they don't have, devices claim they don't have buttons they do have, devices are upside down, and so on and so forth. We started out back in 2014 or something, we started using the hwdb hardware database for this. hwdb hardware database is great. It's like a free key value storage that's basically on every system that uses hwdb. You don't really have to think about it. You just say, oh, yep, there's a key and value. I just want to store that. I'll fetch it later through libwdv. It's great. Gives you arbitrary lookup rules. There's no restrictions as such, so you can match on whatever. So when we were using it, we had matches on DMI, on PID, VID, and so on and so forth. The problem with the hwdb hardware database is as we were accumulating more and more quirks in libinput was that it became virtually unmaintainable. The hardware database is great when you have like one quirk per device. So hwdb uses it for all the key mappings. You have like a crazy laptop keyboard where that key is actually supposed to send escape and not some magic key code. So all these are stored in hwdb anyway. Using it from libinput was a problem because we started using nested things. We, for example, said like all the ELAN touchpads need that quirk. But if it's an ELAN touchpad on that machine, you also need that quirk on top, and so on and so forth. And it became harder and harder to actually debug which quirks were actually applied. So if a user added a hardware database entry and it didn't immediately work, it was kind of like, yeah, you're down to hacking hwdb rules and putting echo foo statements and something in there to figure out why it doesn't match. The second problem is that there was a bug in the hardware database where the matching was effectively implementation dependent, or like the matching how it worked was just because that's the particular hash table they used internally. So you couldn't always rely that the last entry in a file would overwrite the previous entries. Sometimes there was a really weird combination. It mattered how many wildcards you had in your match rules, mattered more than where the actual entry was. So that got fixed very quickly, 3-4 years ago. But because for backwards compatibility, the hardware database has a different matching behavior depending on whether you update it with hwdb admin or with systemd hardware database, which means that the quirk that you ship might work on one machine because it ran systemd hardware database update afterwards, but it might not work on an older machine that still runs hwdb admin. And of course, there's the usual project problem of disconnected configuration. You had the configuration in that section, but then the thing that was using it was like a completely different process. So the main reason why I'm talking about this, if you're ever in that position, start with something like, and you expect it to be complex, start with something like this immediately. It saves you a bunch of work down the line. So what we do now is we have Quirks files like this, so basic configuration file format, ini file format. Second entry here, for example, the marble mouse trackball. So obviously the top one says, okay, that M57 is a trackball because we treat those differently in libinput, different point acceleration and so on and so forth. Or the marble mouse one, you say, okay, this one claims to have a button middle, but it doesn't actually have a button middle. So libinput knows to disable that event code, at which point we have things like middle mouse button emulation enabled by default. So little things like that. We learned the same lesson of like, it's good to start with a hardware database, but it doesn't scale particularly well with libratbag as well. So where we started with that and then eventually switched to a format similar to this as well. Another thing, just a lesson learned as well. We used to have a tool called femu for the last decade or so that would record kernel events. fmu was written with a specific file format, and that file format didn't really extend particularly well. So we started needing more information, so we had to shove things like kernel versions in there, or hit report descriptors. And it wasn't really parsable anymore because there was only so much we could do without breaking the format, at which point it wouldn't work on all the machines. So at some point I decided, bug it up, we rewrite it. So that's how libinput record came to be. This is like the primary debugging tool right now to figure out if a problem is in libinput or in the kernel, because it allows us to record the kernel events and then replay them locally to put libinput on top to reproduce bugs. It uses YAML, which is slightly more extensible because you can just shove new keys in there and everyone else discards it anyway. And the most important thing is libinput record is a debugging tool that sits in the same Git directory as libinput. At the same time as we were starting to push the boundaries of how much we can extend fmu without going crazy, Ubuntu switched to libinput as the main driver. And at that point in time, Ubuntu was shipping an NVMe version that was 2 years old, or 18 months old or something. So it didn't have any of the extra bits that we added in those 18 months because we needed them. So virtually every conversation with the Ubuntu bug reporter was, okay, can you please download the Git repo from there and rerun that command? So eventually I got sick of that because even after, it's like, can you please update this? It still took like 6 months before it actually got updated. And meanwhile, I'm having like all these conversations over and over again every second day. So at this point, I decided, let's ditch that tool. Let's put one into Libinput directly. That way, at least I'm guaranteed it's the same version of whatever Libinput they're using. So main reason I'm talking about this is like, here's a lesson. If you do write debugging tools, make sure they sit in the same repository as the library or whatever you're shipping, because otherwise the distributions are going to go like this. Yeah, that's roughly a short overview of various things we've been doing. There's one thing I want to talk about that's come up in the last few weeks of stuff we're thinking about adding to Libinput, and that's hold gestures. So right now we have swipe gestures. So 3 fingers down on the touchpad, move left, you swipe. We have pinch to zoom or pinch to rotate, whatever you want to use them for on the touchpads. The next thing we're thinking about adding is hold gestures, which gives you a gesture event of like you just put 3 fingers down, but you don't move them. That is a 3-finger hold gesture. 2 fingers down, 2-finger hold gesture. It's a bit of a special case because it's sort of like the fill-in gesture in between the actual interactions. So for example, if you start moving the pointer, you put a finger down, that would be a hold gesture. As soon as you start moving it to control the cursor, that Libinput will go, oh no, it wasn't a hold gesture. It was actually the start of a pointer movement, so we cancel it. So in these particular, there's 2 examples. You would have a hold begin, hold cancel, pointer motion as you move around. 2-finger scroll would be, you put 2 fingers down, you get the hold begin. As you start moving, Libinput goes, oh, whoops, no, sorry, it wasn't cancel that. It's actually pointer axis, so it's a scroll event. But more importantly is, after the scroll event, if you put your 2 fingers down and you hold them there, you get another hold gesture. And that's the thing we're currently aiming for, because it allows you to do a flick to scroll, because kinetic scrolling is implemented in the client. So right now, if you flick, you get the kinetic scrolling in Firefox or GTK or wherever. And the hold gesture would allow you in the client to then detect, oh, after the flick, the users put the finger down, and we can stop the gesture. That's something macOS does, for example. Feels quite natural. You flick, and then once the thing you want scrolls past, you just put the finger down to stop it. No way to do that in Libinput right now, so this is where the hold gestures come in. Allows other things as well, like things, for example, I don't know, 3-finger hold to right-click or something like that. We'll see if clients want to implement that. If you're interested in that or you got any feedback for that, please talk to me. This is really very, very early stages. We only have the documentation, the protocol specs at the moment. We don't actually have any implementation at this point. Yeah, and the summary, just the things I've talked about today. Any questions? Okay. Makes it easy. Thank you very much. Oh.